The most common algebra you're going to need on test number 1 is actually factoring. You guys know how to factor? I hope so, because I'm not teaching you how to factor. All I'm going to do is give you a little bit of a review, a little bit of refresh, and give you a clue that you better go learn how to do the things you don't know how to do, which means come find me or one of the GTAs or A squared. Ask them to help you. Say, this problem, I had no clue how she did it. Help me figure out what she's doing. Because this is a basic part of a calculus problem. So factoring is a huge tool in calculus. Here are the basics. First of all, when you're factoring, you should always look for your best friend. Because if you can find a GCF, a greatest common factor, then your problem shrinks based on what you factor out for your GCF. So if you look at these 3 terms, do you see anything that's in common between all 3 of these terms? What can they all 3 be divided by? 3x. So we write that as 3x, and then parentheses, we write what is left. If we divide each term by 3x, what are we going to end up with? Anybody? Good. Yes, I appreciate assistance. Are we okay? The next 3, oh, that is supposed to be a y down here. Typo. All right. What do you see in common between the next 3 terms? Look at the numbers alone. 2, 6, 5. What do they have in common? Just the numbers, 2, 6, and 5. What can they all be divided by? 1. So is there a GCF for the number part? No. But you gotta have something that's divisible into all of them. In this case, there's nothing. If it helps you, go ahead and write the 1 to keep track of it. All right, do they have any letters in common? They all have x's. What's the smallest number of x's? What's the smallest number of y's? 1y. So that's what you can take out. So our first term turns into, okay, plus
3x.
Yeah, 6 doesn't change. And then x minus 5 and a y. Yep, only the letters change there. And that would be wonderful. Now, all I did was GCF on those 2. Something you could ask yourself is, could they be factored further? The first one could be factored further, but we'll do that later. And the second one absolutely cannot. GCF is just the first step in factoring. Binomials are a very popular problem for factoring because it's, well, everybody's favorite. X squared minus 4. It's called a difference of squares, if you've ever heard that before. That's this one here. And this one at the bottom is called a sum of squares. The name goes with the sign in the middle. So x squared minus 4. Does anybody remember how to factor when you have a difference of squares? Good. It's 2 parentheses. And the insides are basically the same. Basically, not exactly. For example, if you need to break it down and understand why, the x squared has to be broken into the first position of each parenthesis. So what times what will give you x squared? You got to break it up. X times x. So it's the same thing. Or is it perfect square? Break it down. If you have a perfect square, usually that's what you want to use. What number squared is 4? So 2 times 2 is 4. Now, in order for us to end up with no term in the middle, no middle term, no x term, we need what kind of signs here? Opposite. Does it matter which one I put where? No, because parentheses are multiplying. It doesn't matter what order they're in. So that is the difference of squares. If you have x squared and some number squared, that's how you break it down. We good? What if you have x squared plus a number squared? This one cannot be factored. Trust me, somebody will try and find a way, but it cannot be done. However, in some classes, you could factor it. If you wanted to really factor it, you would need to have an imaginary number. We are in real calculus, not imaginary calculus. That is a whole nother ballgame. Have fun. We are in real calculus. We will never deal with I. Everybody good? All right, let's work. Well, that was binomials, so 2 terms. Let's go to trinomials. And just like the last one, we'll keep building in difficulty as we go down these. Now, there are so many techniques for factoring trinomials. I don't care which one you use. Some high schools teach the box method, the cross method, the T method, the AC method. Any other methods I should know about? It's not a Mickey Mouse method yet. No, okay. I don't care how you do it. I do a trial and error. That's how I do it because I have experience. If you have experience, you'll be comfortable with that. If you're not comfortable with that, use your method. I don't care how you factor. This is calculus. Your algebra is up to you as long as it's right. The trial and error goes like this. When you have a trinomial, you're going to want to factor it into two parentheses. I'm assuming the GCF is already taken care of. The first place in each parenthesis must multiply to be the first term. So what times what gives me an x squared? There you go. Is that the only option? If you're going to break it up, yes, that's the only option. All right, and then the last place in each parenthesis has to multiply to be 6. Is that all I have to worry about? I also need it to has to multiply to be 6, and it has to add to be the middle term. This is the most basic trinomial. This is the trinomial where there's no number, no coefficient on the x squared. We'll do the coefficient in a minute. What numbers multiply to be 6? Give me all the options. 6 and 1. What's the other one? Multiply to 6. 2 and 3. Anything else? I could go crazy and put some negatives. Does this problem need negatives? No. So let's look at our options. Which option adds to be 5? So that means that is going to be the pair that we put in here. They are both positives. It does not matter the order. And there you go. That's the factored form. Let's try another one. 2 parentheses. The x squared breaks up into x and x. We need to multiply to be 4. Notice it's a positive 4, but we have to add to be a negative 4. So we need to multiply to be 4, positive. We need to add to be a negative 4. What numbers multiply to be positive 4? -2 and -2. What else? Oh yeah, positive. We could also do both negative. Or we can do both positive 2s. So is that everything? Which of those adds to be -4 though? The one you gave me at the beginning. So I want to reinforce, you have multiple options. Why do you pick the one you pick? What do you notice about these 2 parentheses? So how could I write them? Good. Parentheses squared. Translation. Let's go the other way. More often we go the other way. If you have a parentheses squared, does that mean x squared minus 2 squared? No. Parentheses squared means parentheses times itself. That is a major sticking point on many problems that we deal with. All right, the next one, just to make life exciting, we have a number in front of x squared, so that technique is thrown out the window. We got to start over. This is when all those crazy methods, the AC method, the cross method, box method, all those methods come into play. How you do it is up to you. I do it by just trial and error. For example, I'm going to write 2 parentheses, and I'm going to ask myself, how could I break up this first term? What numbers, what terms multiply to be 3x squared? Yeah, there's not really a choice. 3x and x. There's nothing else out there because it's only 3 times 1 can be 3. Sometimes you'll have choices. We'll work out today. At the end, we have a -2. This time, I am not going to look at the -5 yet. I'm going to look at the -2. I'm going to try. I'll pick something. What numbers multiply to be -2? -2 and 1. Does it work? I tried. How do I know if it works? You multiply it out. I know the first term works. The first term's multiplied to be the first term. I forced that. That was a requirement. The last term's multiplied to be the last term. All I need to check is the middle. The inside and the outside terms. What do they get? So negative 2x, positive 3x. Give us how many x's in the middle? 1x. Is that what I want for my middle term? So trial and error. There's an error here. What do I need to switch? What do I need to fix? Switch the 2 and the 1. So I'm just going to find another spot here. And we're going to try again. So 3x, we're going to leave. X, we're going to leave. There was no choice there. You want to switch the 2 and the 1. So we're going to put the 1 here and the 2 here. Where do you want the negative sign? If I put it on the 1, that means I'm going to get a negative 1x. I need a negative 5. I need the big stuff to be negative. See that? So it actually needs to go on the negative 2. Why? Because if I multiply the inside, I get 1x. If we multiply the outside, what do we get? Therefore, we get our middle term. That is the correct factor. Good? If you don't like my way, I'm open to your way. I just need to refresh you and give you an option. All right, one more of those crazy problems. There is a number in front. So trial and error is how I'm going to approach it. All right, parentheses. What numbers multiply to be 6? Do we have options? What else could it be? Uh-oh, we have options. Options are just more trial and error, maybe. Unless you're lucky. Now, what about the end? What numbers multiply to be the 1 or negative 1, I should say? I need a sign though, don't I? Yeah, I need a negative 1 times a 1. Do I have options there? Just where to put them, really. So really, the most work is actually from the first term. What do you want to try? Hint, the number in the middle is really small. So you really don't want numbers that are far apart, usually. Oops, am I off my screen? My bad. You usually want numbers that are close together if the middle term is small. Okay. What do you want in the first spot? 3x, then the other one has to be 2x, and we know we have to end with a 1 and a 1. The question is, where do we put that negative? How do we check? The middle term comes from the inners and the outers. What do the inners multiply to be? What do the outers multiply to be? Positive 3x. So what do we get? Is that what we wanted for our middle term? But it's close, right? What's wrong with it? Only the sign. So if you swap the sign, that fixes your problem. So this is going to be positive, and this one's going to be negative, and that is your factored form. If only the sign is wrong, switch the signs, and everything is good. Questions? There is more algebra that we're going to need. However, this is the one that you need earliest in the course, factoring. That's why I review it today. If you have other algebra things that come up that you're not sure about, let me know.